For our next stunt, as you can see, I have zap strapped my infrared sensor to the front of the robot and wired up the power and analog lines. Notice where I ran the VCC and ground lines from the sensor. Over here in the corner of the Arduino, right beside the reset button, there's a small 6-pin header, and it can be used for multiple things, but its primary purpose is as one of the serial connections. But it's also got power pins. So when you're looking at the header with the reset button in the upper left, the bottom right pin is plus 5 volts and the bottom left pin is ground. So I ran my power connections there. And then I ran my signal wire over to A0, just like I did before. I've now got my infrared sensor mounted on the front end, and I can use it as a proximity sensor, and we can navigate a room much like the Roomba robot vacuum cleaner does. Also, now, although this is optional, I feel this is very important, and I regret that I forgot to put these on before we did the dance party. I gave my robot some googly eyes. Now, of course, you don't have to do this, but I think it's important. So, before we move on to the obstacle navigation sketch, we should discuss one problem you may have run into already, depending on how much you had your robot dancing. As we move along in our lessons, I did notice that this thing eats batteries for breakfast. These motors and the Arduino itself do use a lot of current, and so it drains the batteries down to a lower voltage pretty fast, and then you start getting brownouts on your Arduino. So if halfway through your sequence the Arduino mysteriously restarts its sequence from the beginning, or it just kind of twitches and doesn't go anywhere, that may be what's going on. Try some fresh batteries. I went through 2 sets with all of my continual testing, revisions, and reprogramming of my dance party sketches for that lesson. You can also try putting on a bigger capacitor as a filter capacitor on your H-bridge, or put it right in the headers on your Arduino's power pins. That might help. There's another serial connection header down on the end, and it too has power pins connected right to the power bus of the Arduino. So you could put a large capacitor on those pins as well, or you could also add a second battery pack either in series or parallel with the one already on there, or even just adding one more battery in series will keep the low voltage above 5 volts, because right now the battery pack is approximately 6 volts when fully charged. So it really doesn't take much of a drop to take it down to below 5 volts. Or you can just do like I did and buy cheap AA batteries in bulk. All right, let's make a game plan here. If you've seen a Roomba in action, they've got multiple infrared sensors and actually do a bit of mapping of the room on the fly. But really, you can accomplish the same thing with just a bumper sensor like we have. Just randomize your movements throughout the room, and when you encounter an obstacle, stop and turn in a random direction. Keep going back and forth over time, and you avoid obstacles and cover the room. So in the infrared obstacle avoidance sketch, what I did was quite simple. I set up a threshold variable, which is a number I decided on in our previous lesson where we experimented with the infrared sensor. Now in my case, I decided that if the analog read from the infrared sensor got below about 50, I felt that that was a positive detection of an obstacle. Now you might have come up with a different number. Whatever number you want, slap that number in there. I set up all the GPIO pins for controlling the H-bridge. Set the robot up for forward movement. And then I used the numbers arrived at by in my calibration sketch in the last lesson to drive an approximate straight line. The raw downloadable sketch will have both of these numbers at 125. I've already modified it to match my robot. You'll probably have different numbers in here. Just change them to whatever numbers you've got in your calibration runs to go in an approximate straight line. So it starts trucking along at a controlled speed, looping through the loop function. And every time it loops, it takes a reading from the infrared sensor. And if the reading is below the threshold, it takes a series of steps. First, it stops the motors and waits for half a second. Now, you don't have to do this part, of course, but I programmed in a delay. It then sets the H-bridge B side for reverse, so the right-hand motor will turn reverse. It then turns the left motor full forward speed and the right motor backwards full speed so that it spins on the spot. Now, if I had programmed the robot to say, so that, say, just the right-hand motor turned backwards, what will happen is that the robot will turn and back up. Now, there may be a wall here or some other obstacle which I wouldn't know about and would not let it back up. But if we spin on the spot, we don't make any changes to our position. So it will rotate to a different direction. Now, I just picked an arbitrary delay time of 300 for the rotation. You may want to make it longer or shorter. I was simply aiming for approximately a 90-degree rotation. Slightly more or slightly less is better, because if it's exactly 90 degrees, you might get trapped simply traveling to the outside perimeter of the room, and that's it. So once it's completed its rotation, I turn off the motors, wait a split second. Again, another delay that is optional, but I liked having these delays in here. And then it goes back to the start of the loop function, which of course sets both motors to turn forwards and then starts to drive forward in a straight line at a controlled speed. It will keep doing this until it meets another obstacle. So flash up your Arduino. Drop your robot in the middle and see what it does. You can fine-tune it as you go along, changing the values of the analog right to change the motor speeds so it, drives in an arc or a better straight line. You can change the threshold values if you're not satisfied with its detection. And of course, you can also add googly eyes.